Welcome to this workshop on CosmWasm. I'm Ethan Frey, the founder of CosmWasm and the creator of many of the smart contracts. Today, I'm going to lead you into creating your own smart contract from scratch with a simple template. So we will start with just a simple template we have called CosmWasm template. And then we will add code for a simple option contract. And I'll show you how to add unit tests for it. That will be the main part of the workshop. It requires you to have Rust already installed and an IDE to work with. I recommend IntelliJ, but VS Code also has good Rust bindings. So please, if you haven't done that already, please install all the needed code. The form of this workshop, I'm going to explain first the contracts we are going to build, and then I will live code the contract code itself and take a break so you can ask questions or try to do it yourself. You should really try to follow along while I'm doing it. After that, I will show you how to write unit tests to verify your contract works. And you'll see the power of doing that, how much easier it is to write than Solidity, for example, to fully test the functionality of your contract and avoid any bugs. After that, I'm going to basically stop the main bulk of the workshop, and we can work with you. You can go on and try to do it yourself if you want to, or break into small groups to work on things. Or you can ask me questions and I can demo more. I can demo how to deploy it to testnet and to run JavaScript tooling to connect to it, which I can show you how to build more complex contracts as well. We have done a number of videos explaining how to build more complex contracts, masterclasses with staking derivatives and CW20 contracts. We also have documentation on how to use the front end. So what we want to do is get people started off and show you how to go from zero to contract in the first place, get all of you ready to start burning and hacking on CosmWasm. So without further ado, I'm going to start presenting the contract itself. The contract is a simple option contract. We're going to start the simplest one we can design. It's a singleton. So one contract holds one option. Let's say you want to offer BTC for Ethereum, and I'm willing to trade one. They're both on this chain. Let's say pegged coins. So let's just call them BTC and ETH, which are really some pegs. And I want to offer, right now, one BTC is about 30 Ethereum. So let's say on an option that I will sell one BTC for 35 Ethereum. That's not very good now, but if BTC moons relative to Ethereum, that's a very nice thing to have. The option might be worth a small money now, and as the Ethereum price goes up, it'll be worth more. So I want to mint this option. What I'm going to do is I'm going to make a contract called an option contract. The way CosmWasm works, you write one contract, generic contract, anyone can upload to this blockchain. So the WASM code is up on the blockchain. That's the heavy part. Then the second step is instantiating it. So once I've uploaded a generic contract for an option, many people can use this contract. It's much cheaper. You don't have to upload the code every time. So it's a quite cheap operation. And at that point, all you do is say, I want to instantiate it with me as a buyer, anyone the seller offering this token for this token, right? So those are the variables. So we're going to see the initialization. We have set the variables. How you want to configure it. So all the configuration you change in ERC20 by changing some constants and variables in the code, you don't do that in the code, you do that in init message. We store that actually in storage. So we define code with no customization, no variables in it, no hard-coded constants. There's also in init. So we're going to show the init message saying who is the original buyer, seller of it, and what tokens are stored in it, and what they're accepting for an offer. And after that, we'll have another one to claim it. An expiration date is very important. Expiration date for the option. So then we have a claim. And so if you are the owner, you have a transfer, I can transfer the option to you. So I can sell it to you basically. So we're not doing the selling on the chain, but you can, in Cosmos, you can send multiple messages in a transaction. So one message can be I sending you some tokens and you sending me this ownership of the option in the same transaction. So that's a seller. So not worrying about doing atomic swap stuff, that's handled by SDK already. So let's think of just the contract. So the contract has a transfer, so I can transfer it. I create it, I own it. I can transfer it to you, exchange for some tokens. You can transfer it to other people. We can trade this option. We can, on the second place, you can exercise it. So if you own it, you can exercise the option by sending the tokens to claim it. So it's 35 Ethereum. At some point, Bitcoin goes up against Ethereum, and it's worth 40 Ethereum. So you want to then send 35 Ethereum, claim your Bitcoin out, and then you can sell your Bitcoin for 40 Ethereum and make a profit. So that's why you have the option for the right of profit. So you have a claim transaction. And the last one is refund. So there are two ways of refunding the transaction. If it expires, then I could just say, okay, I take my money back. So I made my money by creating an option and selling it and let people trade it, but then it expired. And once it expired, I'm the original person with my collateral behind the option. So I need my collateral back. So I have to get it back somehow because no one exercised it. And the other way is if I buy my own option back somehow, I can now exercise my own option by I don't have to put do the trade. I can just burn it basically. So if the original creator and the current owner are the same person, that person can also dissolve the option early. So if it expired, anyone can dissolve it, returning the original collateral to the creator. And if it is, if the original creator owns the contract, they can also dissolve it, returning their collateral. So I'll go over that one more time, and then we'll see it in code. We create a contract. We define a creator and an owner who are the same person. We create a collateral, which is the money sent in that original transaction. And we create a amount desired and an exchange rate for it. So in this case, it is 35 Ethereum for that Bitcoin. Then we have three messages it can handle. So we have a handle method. Handle method means these are actions once it's created. These are basically the execute messages you have for in Ethereum, all the change messages, the aren't view messages. And so we have three of them. We have transfer ownership. So the current owner can change it to another owner. We have exercise, which means the current owner can send the requested amount in there. That money then goes to the original creator, and the collateral is released to that person exercising it, destroying the option as well in the meantime. So it does a lot of things. It sends the money that was embedded to the person doing this. It sends the money sent in to the original owner, and it resolves the option. And the other one is destroy option, basically a burn option, which is done either once expired or if the original creator owns it on their own behalf, they can destroy it. And that recovers the collateral to the original creator. We also can add some query functions to see what the state of the option is. Just show me the state. A lot of other things, we have much more complex states. We have a lot more queries for a lot of different things. We have lists and various things. Show me the balance, show me allowances on this account per this sender and this owner. Send me all allowances on this account, iterate through them. You have lots of configuration for CW20 tokens, for example. But for now, we have a pretty simple situation. So what I'm going to do now is I'm going to show you how to use the CosmWasm template, cargo generate, cargo tools for Rust, cargo generate on CosmWasm template, which will create you just a basic template starting out. It's, I think, a simple counter app. It doesn't do much, but it shows you an app that's working, the minimal thing. We'll go in, we'll change all the messages, the types, we'll define the initialization message, the handle messages, and the query messages we want. We can change the state. We define the different variables you store. So we define the data structures we're storing. And once we've done that, we'll go in and we'll code the actual logic. So I'll go through and take the boilerplate logic and I'll change it, and you'll see how this all matches up. That shouldn't take too long. I'll do a pause after that, and then we'll go to testing our unit tests. So right now, please take a second and make sure you have all of your configuration set up with your Rust tooling, your IDE set up, and yeah, you have cargo. You have cargo and say Rust version, and it should give you something like 1.44, 1.45, something pretty new. So I think we require 1.44.1 or newer for some of the new recent stuff we built. So go please do that. If you have any questions, ask the IT guy. And then in a little bit, I'll come back and I'll show you how to actually build a contract hands-on. So have your IDE ready and you can code along with me. Just type what I'm typing and it'll be your first contract hands-on. See you soon. Okay, so how to get started. The first place to look is docs.cosmwasm.com. This is our center place for all documentation. Please go here in your browser, docs.cosmos.com, and you'll see lots of information. This will really help you getting started, explaining the architecture, testnets we have, showing a few different examples, extra changes, other videos we have, and explaining how to use various contracts we have on live testnets from the client side as well, and how to upload them. This is really an in-depth storage, so today we're just talking about getting started. Before we get started and use the example, we want to click here, Get Started, Installation. First of all, we're only doing Rust now, we're not doing the whole builds, so you want to make sure you have Rust up. Assuming you've never worked with Rust here, you want to make sure you have Rust up, and make sure you also have this in here. Rust up link, you can open it here, and it can show you a command, it'll install Rust up. Click that link here. Once you have Rust up, you basically say get stable, the stable version, and you should get a version that's 145.1 or something. 1 to 44.1 is supported, 1 to 45.2 I think is current, and add this target to it. So that is your first step of getting Rust installed. Please look at this docs. When you go down here, you say on the bottom, set IDE. Explains how to set up VS Code or IntelliJ. And you need to install the RLS plugin for VS Code or the IntelliJ plugin, a Rust plugin for IntelliJ, and explains how to do that here. I prefer IntelliJ with the Rust plugin. Very nice inline messages, and I'll be using that in the demos. If you use the VS Code and that's what you're comfortable with for other coding, install RLS on it, and you won't have to fight with different key bindings. I found it works quite well. It finds errors very nicely. It's a little slower and a few less inline messages, but it does other things quite well as well. It's just I felt the ergonomics is a bit nicer for Rust, but they're both actually very, very good. Rust plugins, both are free. This is IntelliJ Community Edition, it's free, and VS Code is also free. Both plugins are free. Download them on your code and try them out. They support all major operating systems, Windows and Mac and OS X and Windows and Linux. So yeah, go for it. Try one of these out and set this up. Then, while you're doing this, one more thing to do is to look at CosmWasm. I'll write the whole thing. GitHub.com, CosmWasm template. So CosmWasm template is our getting started kit. This really is our starter pack of creating any contract. It sets all the boilerplate up for you and gives you a Rust environment, including Circle CI and GitHub workflows, so you can actually push your repo anywhere and immediately have CI builds working for it, all the control and a basic thing to start working, WASM installation and the whole deal. It also includes a number of files here, like publishing, explaining how to publish code, developing, how to compile code, and various tips on here, importing. So you'll see various useful tips. So this is a great way to start. How I recommend it. The way you do that is you go onto this repo, you install cargo generate. You have to do that one time, and once you've done it one time, you can use CosmWasm template very easily from then. And it uses that utility in order to generate a new project. So when you've gotten that installed, once you've set up your IDE and your Rust setup, and you have installed this with your newest version of Cargo, let's go through and start up a project called Simple Options. I'm going to demonstrate that right now. And you can follow along. I'm going to have a little break in a minute, and you can follow the instructions on the installation docs we'll send in the chat. And the template, which is also going to be in the chat, follow these instructions, and we'll make sure we get this running. So 1 second here. I will switch to my terminal. Great. And now here, we were going to make a directory called HackAtom, for example. And now I will do this, cargo generate, git, github.com, CosmWasm template, and .git, and we that name simple option. Okay, and it goes and it downloads the code and generates our custom one. Great, we have it now. If we're looking at a simple option, boom, we have everything in here. We have examples, we have schemas, it's all set up. So we can open this in our IDE now, and we'll show it in a little bit. And here, what you can also do is just go inside of it and make sure you can build it, or in Cargo build, to make sure everything got installed properly and you have everything properly configured. And you can use Cargo unit test to make sure that unit tests run on it. Then we're going to open it into our IDE. So you can watch me do this in a second. Make sure that it's actually a jet valid code, and we'll open it in our IDE. So my IDE is somewhere else, so I'm going to go open, and I am going to go home Ethan, and I am going to go into HackAtom, simple option, and put it here. And now we see this again here. You see all the code here. We can look into the cargo toml. You see called simple option. Me is the author. Should be your username here, whatever your username is locally, and a few configuration options for this stuff. A bunch of stuff you don't want to deal with. Just it works out of the box. What you can do here, you can do a unit test, for example, to make sure you run the test on it. Once you've built it, it's good because the first time it takes a long time to do these things because it compiles all the dependencies, but after that it's really fast. So run it again, super fast. And cargo build. We also run cargo schema, which generates all the schema files. Great stuff. And we are going to now set everything up. So git add dot and do initial generation from CosmWasm template. So if you break anything, you have, there it is, you have one thing, create that in your directory. If you break anything, go back to here. This is your clean start, and that's great. And then after that, just keep building on it. I like to make git commits every big chunk of work I do. So if I make a mistake later on, I can fix it up. All right. So I will take a little break now, and please try following all these instructions. Go through the links I gave you, and we will, get it working. So get everything working, and then I come in, and I'll start coding this. I'll dig into this file, simple options, and I'll write all the code for the contract in front of you. So please get everything set up so you can code along with me. See you soon. Okay, so by now everyone should have this working. You should have created the simple option files, the project, with cargo generate. And you should have ensured that the tests and the schemas work. This was from schema. We can also look at unit test. And schema is all working. So now you see they run faster the second time, very fast. So we make sure that it builds, we can run tests on it, the schema generates, we have an IDE working, and everything is loaded. So now we can actually start the coding. When you look at source, the first thing you see is lib, with the entry point, which basically is just calling into stuff. What it does is it wraps WASM functions around more Rust functions, and this is basically a Rust function: contract init, contract handle, and contract query. The entry points that I find here, init handle, which basically takes a handle message, which has a number of types, and says based on the type of it, it does a different function. And then query, which again takes that. In Ethereum, you have each of those lots of different functions for everything. The queries are the view functions, they can't change state. And the handle ones are the execute functions that change state. Instead of exposing lots and lots of functions over the FFI boundary, the WASM boundary, what we do is we define a data type, which is an enum, which can represent it all. So we have one JSON object which can represent any possible message, and another one that can represent any possible view. So that's what we have, and we have a init message. So let's start working this option. The first thing you notice here is you take these message types, yeah? And this is where it comes from, message. So you click on it, or you can open message.rs over here. You see message.rs. That's where you want to go. these are the actual types we used to pass in. So we need to think about that. What do we need to pass in? So from here, when initialization, remember we said we have an owner and a creator. So owner and creator, they come from the environment. So whoever signed it. And the collateral comes from the environment. How much money you sent to it, right? And what else do we need here? We need a counteroffer. And we need an expiration date. That's it. So if you have IntelliJ, I use Alt-Enter, and it pops up thing, import, and you see on top, boom, imported this right here. Just all you need for the init message. You say initialization, we set a counteroffer expires. And handle, what are the possible things we can handle? What other types we have? We have a transfer, and that is when I give a new owner, yeah? So recipient is a human address. You see automatically completes up here, over here. So yeah, that's pretty nice. Anyway, again, this is why I recommend a good IDE. VS Code has gotten better recently, but I felt that IntelliJ is very, very nice. Anyway, we can have three things. We can transfer to another owner, change ownership. If you're the owner, we can execute. So we can, exercise the option or execute the option, which takes nothing. You must pay the right amount to it. You must be the owner and pay the right amount, and then you get it. And then we can release collateral. Yeah? Or what's a better name for that? Anyone? How about burn? Yeah, we just burn it. And burn will release collateral if expired. We put 3 slashes here, and that will make Rust docs. So if you look at the documentation, you put 3 of them here. 2 of them are just normal comments for coders, and 3 will say, okay, someone looks at the docs, it explains what they do. Says owner can transfer to a new owner. Owner can post counter offer on unexpired option to collateral. Perfect. So those are 3 actions we need on this thing. And we have a query, and well, we're gonna just have one thing, which is basically, get state, or I don't know, config, and that'll tell us what the current configuration is for it. So let's look at the state we store here. It's kind of like a init message, but it comes from a few more things: owner, creator, and collateral as well. So let's look at the state. So a state thing which shows all the information of the state database. So we define structures. We want to store stuff. We have 2 ways of doing it mainly. Singleton, which says just one. We use this key config and store 1 object. There's only 1 object per contract. That's what you do now. If you have something like a CW20 token, where you have lots of different accounts, we want lots of different structures with 1 lookup key. So we look up by account owner, and then we look up by account owner, and then we have a structure stored for each one. So we can do that as well. Instead of that, we have here just one of them, singleton, because this simple one, we only have 1 thing in the option. So all we need to have state we need to have is, we have the creator, which is a human address. I'll explain. Human addresses are the Bech32 readable addresses, and canonical address are the binary ones, 20 bytes. So all public interfaces that are exposed to the user use human address, and so we use it here as well. But actually, and that's what we want in the messages here. But for storage, you often want canonical address. So we'll simplify it for the simple case. Use human address for storage. There are reasons to use a canonical address in storage. They're shorter, which saves data space. And more importantly, they will last over a fork. So if you have a hard fork, you'll change the Bech32 prefix, or if there's updates. So often we will have different ones. Just letting you know. For now, we're just going to use the same one to make this simple. I'll make a very simple example here, and you can use it for now for coding. I think debug coding, all our production code is using canonical address for state and everything you store long term. But for simple getting going, just use schema address here as well. We'll show you later. You'll see how you can change them. It's a one function call, but makes your code a little longer if you're getting used to stuff. So you can use schema address here. What else did we have? We had the collateral, counteroffer, and expires. So collateral, which is this is a set of coins. Coins are and offer, and expires is a U64, so a block height. And again, we can use Alt Enter, import this. Great. So coin, by the way, is this. It's a denomination is amount. This is a U128-bit integer. It's pretty large. It should hold anything. So the entire ETH supply in Way needs 87 or 88 bits. So 128-bit is plenty good. You don't need 256 for almost any case I can think of. So this is a 128-bit integer. Should store anything. And so in its smallest unit, so we store in Way or in microatoms or whatever else. And these are for native tokens. String is the name of it. When serialized, these are both serialized as strings. UN128 allows us to serialize a string over the JSON boundary, so we can actually handle more than 53 bits of precision. And it then works as a U128 internally in our math library. But yeah, so you basically see this is a denomination, which is like UAtom, and amount is how many of it is. And this is how we represent native coins. So anyway, this is what you have. These are native coins, by the way. So this contract interacts with native coins, not CW20, nothing fancy. It takes native coins. They come over IBC or something like that. So we have this thing. We have these two config options. This allows you a read-write access, and a read-only access to it. They're a little boilerplate. You see later. It's just otherwise you have this little type thing, singleton, blah, blah, and this little type thing. This is simple shortcuts. You cut and paste from this if you want. And it allows us to create singletons that return state. This says, okay, this always returns state. When you query it, you'll always get a state object back, and it'll parse it properly. So now you see the state object we create all the messages here so far. So let's try building it now, and we'll see a bunch of compile errors because we haven't updated the code yet. Wow, there's a lot of errors. So things like we don't know this type because this field doesn't exist, everything else. One thing we do find here is this count response. We don't have a count response, we have a config response now. And actually, config response is just the state. Normally it would be different. If we had a human address, a canonical, there's a difference. So let's just say, config response equals state. Good, so it ports from here. This imports from the create state and says our config response is going to be the same as internal state. Simple, you can define any structure you want here. We should define the structures returned from the query messages. So we defined all the messages. We defined the initial message. We defined the state we store internally. And we've defined the transfer, execute, burn messages we can do, and the config query message. So hopefully this makes sense so far. At this point, we have code doesn't compile at all because it's missing various pieces. We defined the interfaces. All the public interfaces are well defined. Take a second and try to copy all this code. Make sure you have the same thing locally. You see a init message, handle message, query message. We have pub enum here, you see, which has a type, different types here. Type, which is just a type, one is another one, it's an alias. And we have a struct here. These are ways you can create in Rust. And that's a simple structure, an object. So now we have these types. Let's go to the contract. Init, this is how we start. It takes the init message and it returns a response. So this can be a response here. It can do lots of things. You see later it can add logging information. It can return data stored in the blockchain, and it can trigger other messages. So doing this might cause other things to happen. For now, we won't worry about that because init doesn't need to do anything externally. We'll see that later in handle. But for now, basically, we want to take the state and make a state object. So we have this message. env contains all the current information we know about the blockchain state. And then init message is something else, is is information is not trusted from the user. So env is trusted, message is not. It can be anything. But it's coming from the creator, so in init it's pretty safe to trust it because it's the same thing. They're the ones creating it. In handle, you may be separator. env.sender, message sender, is clearly who signed the message, and that's trustable. But if the message contains sender in it, it can be anything. It's not guaranteed. So the first thing, let's do a check here. We can make sure that it's not expired now, right? So let's see. If the message expires is less than or equal to env block height, we have it, then we can return error. And that's how we do an error, standard error, and we do a generic error saying cannot create the expired option. So this is a good sanity check. If someone creates an expired option, there's no point of doing it. So you return error here. Notice that if you turn a result here, standard result, you need to create it, you need to turn an error, error variant, and then standard error, and usually it's generic error. There's a few other types called not found or parse error, but usually it's internally. So if you want to set a message, it should generally be generic error. And then you pass a string you want here. You can format a string if you want. And this says, okay, return error if it's the wrong thing. Now, if it is valid, let's create the state. The state says the creator is the message sender. And we clone. You'll see that a lot in Rust, clone, because basically you give ownership of it. You only can copy it once. Only one person can own something. If you have a bunch of bytes here, a string, and two people own it, they can both modify it, and we have issues. So this says you give a copy of the string. So we give a copy of the string here. Why? Because you need to give another copy here, and we can't have the same string referred to two places. So you'll see clone a lot. If you get errors here, if I don't do clone here, I'll start seeing error somewhere else. You'll see it later. I'll put these back later. You'll see an error. And you see here, boom, used a move value. That means we took it here, moved it, and we didn't here. So typically, if you are passing something, using it more than once, you have to clone on it. What else we have here? We had the collateral. That also comes to environment. Along with the message, we have not just sender, but sent funds. So you see sender is the one that signed it. Sent funds is how much money they sent. So that's actually been, before this happened, the sender of the message deduct that much money from their account, and they sent it to the contract. The contract has received that much money from the creator. So that's guaranteed by the blockchain already before it happens. And now we look at the counteroffer, and that actually comes to the message. And expires also comes from the message. So now we've basically set this state, and we just do save it and say everything's fine. So that's initialization. Do you see this so far? We have verified it's not expired. We take information both from the environment, the message sender, and the message sent funds, which are guaranteed to be true. We're not trusting them how much money. We said we've already moved that money. So this is, like Ethereum. You can send money along with the transaction. And we take this configuration, what the desired counteroffer and the expiration date, from the message. So that means we can create lots of different ones. We can trade anything for anything when you create it, depending how much money you send in to create it, and what counteroffer you request, expiration date. So you can create many, many different options to the same code. That means we upload this code one time, and many, many different people can use it for many, many different things. But any sort of option. We don't have to upload this code a second time. The handle message, we go through this match statement, and we see the different matches. We have transfer, execute, and burn. So the first thing you do is boilerplate. You basically just do transfer to recipient, and you can do something like handle transfer environment and recipient. So great, and now we can, what are the handle messages? We have burn, we have execute, and that takes no arguments. The dependencies here, again, the dependencies are storage, your read and write access to your local storage of the contract. API, which allows you to do stuff like change canonical human addresses. Maybe it has, you know, some precompiles later on, various other things to call into the system, which are stateless. And query allows stateful queries into various parts of the system. So if you want to see what your balance is, or what the balance of another account is, what is in stake, or what is the, you know, current status of another contract, use the querier, which is stateful. So now those all call back into the Go runtime. All this calls back into the SDK thing. So anyway, handle message. And what else do we want to burn? Yeah, we have burn. So let's burn that too. So we define these 3 activities we can do. This is boilerplate, and you know, so far this is a bit of boilerplate. So we define a list of all possible actions. These are the ones that are exported. Nothing can be accidentally exported by forgetting a keyword. It's explicitly defined which ones are there. So then we have a mapping here. This handle function is basically boilerplate. If you use the Cosmos SDK, you'll recognize that boilerplate too. It's a little more concise here in our code, but similar. If you use Ethereum, you'll see these functions here, and that's basically what we want to end up with. And this is what we use to Ethereum, so we just add this little, you know, a switch statement around them. Once we have this, let's go through and define how it works. So handle transfer. That takes a environment, and it will take a recipient, which is a human address. And we have to import that one. Alt, enter, and you import it. So what do we do here now? Let's just go here and start from scratch. What I want to do in the transfer is I want to say ensure message sender is the owner, yeah? And then set new owner on state. So let's see how we do that. Let's go. So if the environment, the message sender, does not equal the current owner, return error, send error. And we've unauthorized for this one, because this is a very, very common thing. Unauthorized, not allowed to do it. Great. So that is how we return this, but where's the state coming from? We have to load it explicitly. We don't automatically load things magically for you and save it. It's a little more overhead for simple contracts. For more complex ones, it's much more efficient. And you'll appreciate that control later. So just get used to a little bit. It's not so hard. We use mute here because we're going to change it. Another Rust keyword. And we do config deps.state mute. And we do load. So question mark. So this question mark says, you know, if before that, you see over here it says standard result state. And this is really cool to have this stuff, by the way. So we return a result that may have a state in it, because it might be an error. So it means this question mark is if error does not equal nil, return error in Go. Because it says if this was returning a standard result and this is returning a standard result, the question mark says, well, if it returns a standard result, return that result error message right away. If it's an error, otherwise take the OK case, which is the good case. And if you're new to Rust, you should really learn results. This is basically a core result. It's with a special error type. So you look up that result in, and the result and option types in the standard core library of Rust are very, very important, and you'll be learning them a lot here. Anyway, so we have this, we've loaded the state, and we verified that the sender is the current owner. So now we are going to update the owner. So the owner is equal to recipient. Awesome. We just now set the owner to the recipient. So we update the owner, and now we just save it. So config so this will save it. We need to save something here. Save state. Awesome. So we save the data here, and now so this saves it. We load the state. Basically, if you look at it this way, We load the state, making sure the sender's the correct owner. We change the owner and save it. And now we can return something. So I will say the result is a... we'll probably rename this soon. You'll find out context is a way of building results. So if we want to do something response, we can do something. We'll see here right now what I do here is add log, and we can do action transfer. These will go into the Cosmos SDK event logs. This is kind of right here like a MIT. So this is a new owner. So, you know, and transfer, and the new owner is this. So we can search for who the owner is, maybe call it owner even. So at this point, the owner becomes the new owner. Yeah? And then we can do OK into. The problem you see here is two things. One, we need to get mutable, so we can change it. Show that red there. And here it says we're using it already. So we just do clone here. Hopefully it makes sense now. What we have done now is we have loaded the state. We ensure that the owner is the one calling it. If so, we set the owner in the state and save the state. And now we produce some emit some variables. So it's relatively short. You have to learn this API a little bit. But yeah, you see this config stuff coming from state. And this is basically, you know, you write these little helpers. You'll see some other stuff. You can look in some sample contracts and get a good hang of how we use a singleton bucket. It's probably the best way of learning the API. You can also look at the Rust docs for CosmWasm storage, which defines all these, or CosmWasm SDK. Often I click to things, you know, in the IDE to see what's going on behind it, and explains what this does. So maybe a little more confusing for you if you're not used to Rust. These are kind of some complex data types. But in the end, it has new, is save, remove, load, may load, update. And so you can look at the Rust docs to kind of explain a little more how this works. You'll have to worry about the internals of this phantom data stuff. Anyway, going back to the contract, you see how we wrote a simple transfer function. Yeah? Let's go to a more complex one, which is, and so I will, you know, copy this one, basically. And I'll get rid of this other try reset. That was, you know, a different way of doing stuff. Let's get rid of that. And we want handle execute. I believe that's what we called it. Handle execute. And we have no more arguments here. So execute, we want to make sure that the message sender is the owner. Yeah? Hey, looks similar. We also want to do is ensure not expired. Ensure sending proper counteroffer. So you have to pay the amount of money in the thing. That's great. So that's not expired, the owner, and the sending a proper counteroffer. Is that what we defined here? Unexpired option. Owner can post counteroffer to unexpired option to get the collateral. Great. So we want to do this. And in the case this happens, if that's true, then we will release counteroffer to creator, release collateral to sender, message sender, and then we will delete the option because it's done. So good? So at this point, let's just check the stuff. So great, we've checked the state. It's not the owner, right? So unauthorized. If the block height is greater than or equal to the expires time, then we turn another error. And this time we just do a generic error maybe, and say option expired. We make sure that they're a proper thing, and we can do, there's a lot of definitions equals everything sort, so we can do something saying message, env message sent funds doesn't equal state
counteroffer. If it's not the right one, then we can go here, another generic error, and say must send exact counteroffer. And actually, maybe we want to have something else explain what the counteroffer is. So we can use this format must send exact counteroffer, and we'll say display. We don't. So this is debug information. Maybe it's not the best one, but something. It'll give you more a debug version of it, and not the full display one. We can define display, which creates nice human readable versions of these. But right now we don't have it. But so yeah, this says basically must send exact counteroffer, and it will return you an output of the list of coins is required. So this is how you can make useful error messages as well with format, which is like printf, sprintf. Now I've ensured that the owner is sending it, it's not expired, and it is the proper amount of funds. So now what we do, let's create this context again. So we create the new context, and what you do here. So what you do here now is you add message. The way you send money is bank message, send. There are a few other ones, you can look these up. It's called Cosmos message. So you can, so if you go here, is Alt Enter will allow you to add missing fields. So you have the list of what you can, do pass here. The from address is the contract address, also in the environment. So you really want to check out this environment variable. You can go here and see what's in here. The block info, message info, contract info. You can see information you have here: height, time, chain ID, sender, sent funds, address. So you can look at all this information easily, and this environment gives you a lot of information. It's useful. So yeah, we take the contract address, is sending it, and we're sending it to who? The original creator, and that is the state creator. And we're going to send the counteroffer there, because that's how much money was sent. And now the other one is slightly different. We send from the contract address to the owner who executed this contract, and we're going to send all the collateral. And so you see this message here, use of moved value. We just have to clone it once, and everything is fine. Now delete it. That's pretty easy. Config, just like you see here. Config mute depth state, and we just do remove and delete it. We've already created that context. Now we can add action is execute, and the owner, I don't know, if it's execute, it's done. Yeah. So so we execute the option and it worked. So this means that these messages will be returned. They're not executed in line, they're returned from the contract, and they're executed in the same transaction asynchronously. This is kind of the actor model, and this avoids reentrancy. The whole design of this avoids all the reentrancy, gas checks, all these things in explicit in Ethereum. We just define these types here. So we have these add messages, and so all these messages will be executed in the same transaction. If the messages fail for some reason, all of this function will also be reverted. So you can optimistically do the things you expect to work. We know that we received this money, this amount before and this amount before, because they were checked in the two functions, this function and init function. So we know we have it. But if you try to send it and don't have the money for it, it would fail. This whole transaction will be reverted as well. So we optimistically do these. You can look at Cosmos message that you can call into WASM. You can call staking modules, and a few other things you can call, custom ones possibly. So you can add messages, which will do other actions. We'll call into the thing. And you can add log messages, which are just stored in the transaction to allow to query the state. Finally, we have one more here, which is handle burn. So let's do handle burn. Let's copy handle execute and do that. And handle burn is a little simpler. but it's a lot similar. So in handle burn, we want to make sure that anyone can be the owner, actually. We ensure it is expired. So if block height is less than expired, then option not yet expired. Don't have to send any money with this. Please don't send any money with it. In fact, it could do something else to make sure you don't send money with it and get stuck in the contract. And if the sent funds if it's not empty. So if you send any money at all with this message here, if it's not empty, then we said something. Don't send funds with burn. Perfect. So we guarantee they don't make them lose their money. If you send money to the contract here and we store the contract, then that money is just locked up in nowhere land and no one can ever access it. So we can be a safety check here to make sure people don't send money this way. At this point, we only have to release the collateral to the original creator. So the creator gets the original collateral. And that is how to do that. From the contract to the creator, and we send the collateral. We don't send anything else, only one side, just return it, and we can do burn. It's getting simpler to you guys. You see this, how it's going? Check it is expired, make sure there's no money sent with it, send a message to the creator with the amount of collateral, the original collateral, to get out of it, and then we store the contract. There's no more usage of it. And then we tell, hey guys, this is a burn. If you're looking on the transaction history in your block explorer, you'll find it as burn. So hopefully this is getting a little more clear. And we can do a query, just to show you the other side of it. There's a config type. So let's do the config type. So config, and we store the data, and we can do query config again. What you see here is two binary, basically encodes it to binary. Binary is a vector, but it's basically, we use binary things that are base 64 encoded. So this means it'll be base 64 encoded in JSON in some other structure. So and we have this kind of pattern here, return it, and these internal functions will actually return a proper type, which is easier to run in tests. So we can use them in test code, and we know these query ones will return a proper type. At this point, we want to return a config response. Yeah? So we return a config response. So the simplest thing here actually is all we need is this. Since we're in the same type, is this. So we just say config read and read the storage and load the data. Since we do the exact same type, because we chose this same type, right? But let's make it a little more explicit. We can say, let state equals this. Normally you'd return then some transformation on that possibly, but we can just do, okay state. If I have this semicolon, it means don't return anything. If I leave it with no semicolon at the very end, it means return that value as the result of the, this is the same as this. So at this point, we have basically written everything. So we can try cargo build, and it build, yeah. There's some issues here. Let's see. Let's go through these issues here. Quite a few issues in my code. So create message contracts 3. I have a count response still from the old code. I have this one here, which imported accidentally, auto imported accidentally. 109 is saying I mistyped here. I never load the state. Remember I just lead something here? So maybe I should make sure I load the state first. That'd be good. There, so we have to load the state first. And now let's see if it compiles a little better. All right, we got a fewer errors. Canonical address we don't use anymore. That was good because we got rid of that idea of canonical address to make it simpler for you guys. Dep state. Yeah, there's no state. I must have mistyped this somewhere in 46. It's depth storage. Great. I did it a few places, didn't I? Yeah, so just a few typos here. Which are cut and pasted, and there. Alright, let's see if the compiler's happy now. Have a little closer. All it says now is these ones are immutable. That's good. So they're warnings now. It says that we don't change the state. Remember in the transfer, we call it mutable state because we're going to change the owner of it before we save it again. In these, you don't modify state. You load it and then compare it before deleting it. So we can remove that mute keyword. The mute means if it's not, it's good to remove these if we don't need them. It means this is never going to change, immutable, and that's more towards the functional style of programming and security. So great, it works. The next thing you want to do is comment cargo format, and that will fix a few things. Your layouts, you'll make sure all your spacing is right. It will sort stuff up here. You'll see these sort changes around a little more here and here. These things are all alphabetically ordered now, so it makes it a little better. In a cargo clippy if you want for other stuff, but this is pretty good. So now what we can do is, it said wrote core logic code. Great. So I've just written all the core logic for function. So what was that, half an hour we were set together here, and we've written a contract. We've gone for your first contract. I'll give you a little time to catch up on this. You can try writing this yourself. Make sure the messages we have are all the same. You have these message types defined: handle message and init message and query message. Make sure the state is the state, and the rest of it just kind of comes from itself. So we can look at this handle message. I will sit there and you can try coding along with me. Make sure the state is set there and saving it. We'll post a link probably to the final solution if you want to look at it, but you can also just try writing this yourself. I'll give you a chance to it, and at the time you finish writing it, query. You want to make sure that cargo build worked, and then try cargo format. Yeah. We will take a small break now, and I'll come back to you and show you how to write tests and get the schema generation working. Welcome back. At this point, you should have your code compiling, and hopefully the key guys help you out by this point. So you should be able to build this contract and figure out how to get a working contract. Again, it's not so complex, but hopefully this made sense to you. What we want to do now is try to work on the two things, which are test and schema. There's two commands. The first one is easier. It's cargo schema, and it's going to fail because of import error. You probably recognize this one. No count response, a message. Config response. We changed something. Look at what's this example schema file. So if we go in here, we see this schema which shows actually all the JSON schemas. It gives things like what a handle message looks like, which is in JSON schema, which you can import and auto-generate TypeScript definitions or Go code from. So we say any of this increment. What's that object? And reset. These are old ones with old code. This is out of date. Let's make sure these are up to date. So I need to go into schema, and I am going to fix this. So we have a config response object here, and a handle, init, and query message always should be here involved. The state we actually don't need anymore because you don't need to export the external state. That's internal details. And let's just clean it up here. So at this point now we say it will find the schema directory here. It'll create a directory and remove all the current schemas. Then I'll regenerate all of these. I'll take the init message object, handle message, query message, and config response, and generate files for them here. So let's try this now. So I do a cargo schema. These changes, and it's changed now. A few things here, and well, this is called config response is now called state because that's really what it is. So so export schema with title. I have this one here, and that will allow me to do will call it something else. So if I want to call it something else, I can do this actually. It's a nice trick. Because it's an type alias, so the real name of the structure is state. That's correct. When it generates, it is really state object. But I want to have a different title because I call it my code config response, and I'll call it also config response. So now I just basically tell it export schema title, and I can have custom title for it. Otherwise, it takes a real name of the code in the code of what that is. The type alias. Run this again. Config response now. So we see the config response with the array of collateral, counteroffer, creator, expires. Yeah. We can see the handle message, which says owner can transfer to new owner. The Rust doc you put in here turns into a description, which is pretty cool. Yeah, so it actually goes into your JSON description as well. And that's your Rust stuff. And it says it takes one transfer. It has one object which is called a recipient, and that is a human address. Execute is any object, it's an empty object, and burn is an empty object. So all descriptions here as well. So we've currently defined all these types. This is very useful when building clients for it because we defined the ABIs. This is kind of the Ethereum ABI. So define the API for all these contracts. So let's finish all the schema stuff. And now that's good. And I want to go here and I'll say that's great. So I'll get cargo format again. And I will say let us delete some files, add some others, and update schema. You always want to make sure that's up to date. It's tested in these, I think some of these Circle CI stuff will also run through here, and it will make sure the schema is there. It will do this stuff here to make sure that it runs the schema, and it'll make sure it's not is proper up to date. So you can use it in CI as well. This will do all the tests for you. Last thing we have here is we want to make the code work, right? The test work. So let's go see how the code test work. Proper initialization. We want to make sure this works. So mock dependency sets up a base thing with no contract balance. And let's create an init message. And then the message is going to be, we're going to offer 1 Bitcoin as collateral, and we want a counteroffer of 40 Ethereum. Yeah? So we call it coins, and we can do 40 ETH. Yeah, there assumes a pegged ETH in our contract, and expires is some time in the future. The creator is creating it, and they are sending 1 Bitcoin. So they're locking 1 Bitcoin option, and they're waiting for 40 ETH to claim it. We did create it and make sure nothing happened. And now let's go through and do query config. Yeah, so query config does nothing. And this is simpler. Then let's just say, we can insert things. So what do you need here? We want that 100,000 is the result, the expires time. Yeah? We want to that creator is the owner, and creator is also the creator. And what else do we want to know here? We can make sure that the we have 1 BTC was properly set as the collateral. We didn't mess these up anywhere, and they're the same type, so it's good to double check this because maybe you mix these two terms. And 40 is the counteroffer. So we just defined this this test. That's great. No crazy JS here. We call a init function on it, and then we verify it is. And these deps hold a local storage to mock storage, meaning it's just a memory. That works. Let's comment out the other ones now to see if this works. And let's see if the tests work. So at this point, cargo test should run this one function. It complains a little bit because I don't need these things yet, and it says yes, it worked. So let's get rid of the unneeded there, and it passes. Perfect. That was fast. No running up nodes, nothing deploying code or anything. It's just pure, really fast Rust code. You can get full responses, error messages here. So if I do something like, I want it to be 2 BTC, I will, test, and it will tell me, hey, look, it expected 2 and it's really 1, which is pretty nice. So I can do all kinds of checks I want here as well. Let's go here. I want to execute it. So let's try execute. So I'm going to basically do the same init message. Let's just do the init thing here. And, or transfer really. We should do transfer first. And this is how you create it. So we're just going to copy the same stuff. This is basically creation code to make sure to initialize it properly. The same, the same test for everything. So let's call it transfer. Test transfer. And we have this. So what can we do now? Now we have it's transferred. Let's make sure that someone else cannot do it, Random cannot transfer. And owner can transfer. Okay? So to do that, we just create a new environment. So you see here, anyone. We don't need any coins here. So say this means anyone is calling it. If anyone or some random person calls, and you can do this thing here. This is nice to create these types, or you can call it directly into the. We can do this proper thing, which is transfer. We call handle transfer to make sure we do the whole checks here. I was complaining. Transfer to anyone. Yeah. So. So I can make that. So it's trying to transfer. So anyone's trying to transfer themselves, right? They're trying to steal it, basically, and they can't do it. And we can have an error here. So it should return error. We could also simplify this. We can make this whole type. We can just call the function directly because that match statement doesn't need to test it too much. You can do it simpler and just do handle transfer. Depths, env, and the recipient. We pass the recipient here. Yeah? So we can just call this. And we want an error to happen here. Yeah? So let's make sure it's an error. And unwrap, and basically you see above, will panic if this is a error. It'll just panic right there, and you get an error message saying, "Hey, this was a failure. You need to expect success." This is I expect an error, so we can test it. And now we are going to expect, on the error, and unauthorized. Dot means anything there, and so if it's unauthorized, great. And otherwise, why do we get another error? It would be, we can just do panic unexpected error. So hopefully this makes sense. So you test the error type here. So you can, right here we say, this is pretty simple. On a Ethereum test, it's a lot more complex. We've initiated a contract here. Now we said call this function. Anyone is calling it with person anyone. They are trying to transfer into their name, and we get an error back. The error is an unauthorized error. So we don't just guarantee errors somehow, errors for that exact same reason, right? But now let's make sure the owner can transfer it. That's very similar. A little different. And so let's say the mock environment is actually the creator now, is doing it, and they're transferring it to anyone, to someone. Sure, yeah? And this time it should be unwrap, because we expect success. And that should work for success. And we can even do something like that, and we can do assert equal res.log.leng is 2. We want 2 messages here, right? And we can do log 0 is action great. So we can even see the log message to make sure that it was properly translated. And then let's make sure actually to query it. We can do another query and see the owner has changed. We can copy some code from here. We don't need all of those. We just want everything to be different. What we want to do is basically say that at this point we load the properly. Query the config response. The creator owner, the creator is the creator, and the owner is now set to be someone. Make sense? So we've gone through, we've executed this one, showed how to test for an error condition. We validated error and exactly what type of error it is. You don't have to do this part. You can just, if you don't want to care about it, you just do this _error and ignore it and just say unwrap error, and ensure it failed. And this way allows us to test exact error type. You verify it's successful with the unwrap, and you verify even the log messages, which just showing you how to do it. You don't have to do that. We can just verify success if you want to. Simple. And then we can query the new state and say, hey, look, the state changed as we expected. So let's see if this works. And did I fix the other one up, by the way? Yeah. Great. So proper initialization passed and transfer passed. That's super fast testing, isn't it? Less than 1 second. So I've done that too. We've transferred is working. So we can keep writing this for the other tests. I'm going to show you, and you can do it on your own. You can start on your own. I'm going to do this. In the meantime, I'm going to talk a little bit, and I encourage you to just do this on your own while not watching me too much. If you want to, you can just ignore me and look at this video later. But right now, and I'll push all this code. You can refer to it later. But so I'm going to do it now for anyone that wants to just follow along. So execute it. Execute. We create again the same contract. We want to make sure that worked. The random, we don't even need this check anymore. So what execute? Random cannot execute. Yeah. So this should give an error. It's unauthorized. Great. And we also want expired, right? And actually sent needs to be the counteroffer. Yeah. I should make this here. So you define this here. Let counter offer equals this, and we can use various places. Clone. Yeah. So we're cloning the counter offer. We can then say, okay, let's make sure that we have we send the counteroffer. So the proper amount, but the wrong person. So we want this to be failed unauthorized. We say expired cannot execute. Well, we created this one with a really high expire date, so let's do something here. I'm going to take this mute here. I'll set to creator, who's actually the owner. And now I'm going to say, let's say env.block.height equals 200,000. We've expired it now. And this one should expire with a generic error. And you can do something like assert message.contains what is the message we sent out for its to here. We can look back here what expected. Then execute, it expires, option expired, or blah blah. So option expired. So let's just make sure that message is we can actually equal here. So message assert equal option expired as string. You have to put the right type. And this it says otherwise make sure that the message is this, otherwise we panic. So we can do really nice error testing here. Not just expired for something or some error, but actually this is failed because of the owner, and this failed because it is expired. So we can make sure the right tests are being checked, not just it fails something else because, hey, we forgot to set the proper counteroffer here, you know, because we did this, and it's failing because of the amount of money and not because of the expiration date. So we make sure that everything is properly set. And now we have bad counter offer can expire. So we have the same environment variable, except here let's have a different counteroffer. So, you know, coins, we send, you know, 39 ETH instead of 40. Yeah? A little too low. And this should fail, and we can do something like this, that, you know, assert message dot contains, and, you know, I don't know, offer, something like that. I think it's supposed to counteroffer or whatever it's supposed to be. We'll see. Probably something the bad counteroffer, right? Interesting counteroffer. So we want to make sure this counteroffer thing, and here's error. So we've tested all those cases, and now let's make sure a proper execution, yeah, works. So you're seeing we're going through all of those code blocks, all of the if statements are being executed, making sure every single check is properly working. At this point, we said a creator sends it with the counteroffer, the proper counteroffer, and actually all these are wrong because we're calling handle transfer. These all should be handle execute. So we'll actually see this as fail. I'll leave this now and then fix it later because my test case will fail. And the execute should be, I actually want messages. Too long. It should be 2 messages back, yeah? This is properly done. And we can make sure that is query config is nothing, so we don't need the config is deleted. We can do check deleted. Yeah? So we can test the messages are sent properly out of it. So we sent the proper messages out, and then make sure it's deleted. Then make sure there's an error. At this point, querying it should give an error. So I'll try testing it, and I'll give you a message here. That doesn't make sense. So we're actually using the result in 2021. Ah, yeah. So we can just, you know, underscore, meaning ignore it. And we should see an error message saying, hey, it cannot get an OK value on blah, blah, blah. What? Transfer. What's that going on here? So this is 244. So when we call the transfer one with the wrong amount of money, it's not complaining. Oh, expire can execute because there's no check like this. Oh, wait, maybe we're doing the wrong thing here. So clearly this message of unauthorized is working, but we should call handle execute maybe and not pass the recipient. That's what you need to do. Too much cut and paste here. But since we're testing all these actual conditions and testing the error messages from them, we found out we're doing the wrong thing pretty early on. Now let's try this again, and execute should be here too. Okay, failed. And what happened? So assertion failed, message contains counteroffer. Ah, maybe it's the wrong thing. Let's look at what it stores. Counter underscore offer. Well, I'll change that. That looks better, right? Must contain exact counter offer with no underscore. That's probably a better solution. And test pass now. Awesome. So we actually test the error messages are proper and look good. So far, this tests the execution, and we can make sure the execution messages are as we expect. We can do result messages 0 is this is Cosmos message bank message send, and the from address is the generic contract address we can import everywhere, which is what is it, string? Yeah, so you can do into actually, because I think it should give us this. Yeah, great. So use into to turn it into human address. So anyway, the mock contract address is unit global, so for all the test cases we use one address for everything. So it's from the mock contract. 2 should be the original. It should be the. Oh wait. The problem is the creator is the owner and the the executor. So maybe we add another call here first. So clearly I'm finding a problem in test case. So we're going to first transfer this one time to someone else. Yeah. So init works, and now let's do this thing here, and the creator is going to transfer it to the owner. So we know this works already from before, so we just say, okay, do this. So now, okay, so the creator creates it, and the owner now is the owner of it. So random person can execute it, and we actually want the owner to be able to execute it. And we call it here, and the owner's one should be able to do all this. And now the to address should be the original creator. Into is a magic word you'll see everywhere, and the amount should be the original collateral, which was what coins 1 BTC. Yeah. So that makes sure that they're actually sending this guy the amount of money. And I want to make sure the other one that we send the owner. No, that's not right. We're saying the owner the 1 BTC, and we're saying the creator the original collateral. The counteroffer. The counteroffer goes to the owner, and the collateral goes here. Also find this better above. And the owner gets a collateral. The owner gets a collateral out of it, and the creator gets a counteroffer. So we'll make sure we set this properly here by defining this here, and let collateral okay, that makes sense now. So we find the collateral and the counteroffer so we can use them later. We create initial message asking for this and try it out. We set a new owner so we can test it better. The environment, the creator, now we'll set a new owner. And we assume it works because test above. Random person, anyone can execute it. Expired can execute it. And owner can execute it. We can even try the creator. We can make sure that the creator cannot execute anymore here, because the creator no longer can execute this because they all transferred it. The bad counteroffer is not working. With a good counteroffer, we got 2 messages off, and message 0 is saying send the creator the counteroffer, and then send the owner the collateral. And there should be no deleted thing. So that's a big chunk here. That's a whole lot big chunk here in execute. So let's see if this works. All right, it's working still. So we've done all the full tests for it. So this is pretty cool. Only thing we have left is burn. Burn is kind of like execute, but a little simpler. So let's just take this function, this test code, cut and paste it. So these all don't need anymore. And what do you want here? So execute is here. So we set this up properly, set the environment, init. So we set a new owner on it. That's great. And actually, it doesn't matter because anyone can execute it. Whatever. Let's have a new owner anyway. It's good. And we say anyone can execute, and it says non-expired can execute, and expired returns funds. So we just go here, set the environment. Here we don't set the block height. If you call execute, it should say something and not expired. Yeah? Something like this. And then if it is expired, we set this here, it should work. So let's see some working. Watch how we test this case. If it works, it should look something like this. So you can use the same code you figured out before. See, we set the expiration and make it expired. We call execute on it. We should get exactly 1 message, and that should go to the creator and actually the original collateral. Not that. Fair enough? That's all we need to test. And making sure it's deleted as well. So hopefully it wasn't too fast for you. We go through it again. We cut and paste from execute to burn now. is execute is up here. Burn is like execute. It goes through, it initializes a message with the same trade. It calls init. It transfers it to a new owner. If is make anyone is calling it, and actually should have no money on it. Oh, that was another case we tested, wasn't it? And so let's make sure here with funds can execute. Remember we tested that one? Remember that code we added before? So if we send some money to it, it won't work anyway, even if we set the block height properly. So even if we make it expired and set the block height to be 200,000, it won't properly work. It will get something about okay. And then we get the thing, if it is expired, and if anyone does it with no money on it and is expired. So here we have no money and it is not expired. Here we have money and it is expired. And here we have no money and expired. And that's good, and this returns a proper value. So we try these 3 cases, and let's see if this works. Maybe code is wrong. All right, it is unauthorized. So where's that? In 306. I'm calling handle execute. Oh, of course it's failing. Calling execute and handle there. So let's call burn and burn. That should be a little more intelligent. No send funds. Don't send funds with burn. Actually, there's a little typo there, isn't it? Don't send funds with burn. So don't send funds with burn. That sounds a better message. Let's try it again. All right, great. That's amazing. It's working. We can do a good cargo format to make sure everything's laid out nicely. There's little things like this. Don't send funds with burn. So make sure the messages are proper, expired in this. And all the cases have been tested. We've pretty much, I think, got 100% branch coverage over this. And we've covered, I think, all the branches of all this code. So take some time getting used to Rust. If once you get Rust, it should be pretty good. And you might notice that you can really, really get good test coverage of it, really proper things. So when you deploy your smart contract and test it from the client side, it just works. There's no problem with it. It just works. I'm going to stop this praise. Please go yourself. Try this again if you're still struggling to follow up. Keep writing those unit tests yourself. Make sure you can test those unit tests. Check this out. And I'll be back in a little bit to take some question answers from you guys. So right now I've gone a little fast over all these pieces, and I want you to try it out. I've showed you how it goes. So now I'm going to sit there and you can try it out for a little bit. We take a little break, coding break yourself. Check in the IT guy lab if you have any compile issues, you can't figure it out. And a little bit I'm going to come back for more advanced use cases. So we can try, if you have trouble with one thing, if a lot of people have questions, we can go into one of these issues. How to test this, how to fix this. If you want to learn how to deploy to blockchain, we can cover that. If you want to learn how to write more advanced use cases and how we do something more complex using buckets and as a real token, we can do that for a little bit. Although much of that is covered in master classes. There's some videos of that. This should give you the basics to try to start getting up to the level of master classes. So more or less all the techniques you need to do to write your own contract. Please think of that stuff. Try out for about 15 minutes or so, and then let's come back and let's just go and refine everything. All the questions you have, we'll answer, and we'll make sure that this is easy for you to do. You get this down, you've got your contract basics down, and now you can just start writing new code. You'll know how to update the state, and you can add new buckets of state. You know how to define all the messages, and you know how to initialize the code, how to handle all the messages, how to execute stuff, how to send tokens around, do queries, and write full test coverage in unit tests. So that's full test coverage here in unit tests, guaranteeing very high quality code without having to use, temporary nodes and Ganache and Truffle and all kinds of other stuff and write JavaScript tests for your Solidity code, you have really, really nice test coverage here. Great. So hope that works for you guys. I'm going to commit this, and it should be online. Let's see. Add unit test. Good. So I have the unit test here. I'm going to push this off to a repo, and you'll have a link to this repo. You can look at that repo in reference while you are coding. So have fun. And any questions, come ask in the session window, and we'll have more code for you soon. Bye-bye.
Hello, see me, Akun?
Hey there.
Hey, hey,
How are we?
cool. Can you hear me good?
How's it going?
Or is it too much noise in the background? If the lag is too bad, let me know, and I'll kill the video.
Keep on. No problem.
Great. I'll just kill time for a little bit. Thank you. Thank you for getting us together. It's been, yeah.
Changed. New.
Hmm?
Headphones.
I have headphones. Yeah, new headphones. Well, kind of.
Cool.
They're for my girlfriend. Your sound is a bit choppy for me.
Good. For me.
Let's kill my video. Let's see if it works. I kill my video. Yeah, maybe I can hear you better now. So.
Yeah.
Hey, Hima-san.
Hey, Ethan.
Cool. I was trying my video, testing out my my connection. Seems good. See how it compares to the video now. Thank you very much for this. I'm sorry. Yeah. And
Thank you.
I tell you more later, offline. But
Okay, so there are 6 people watching us.
Great, great. Any questions?
Or any comments, any feedback?
Can video or chat on the session chat.
Orkun, you're kind of breaking out.
Voice or video?
Let's see. So who's here on this meeting?
I think almost everybody is from India.
Okay. Great.
Yeah.
Anyone want to talk? So I've built a lot of stuff. I will send you, again, the docs here. You're more than welcome to build docs. So I can tell you a little bit more. I started building CosmWasm, a hackathon. So 15 months ago, it was a hackathon project, just like you guys are building. And so you can build something amazing on it. I'd love to see people build amazing stuff. It really was a prototype and a little part-time job and a small grant. And starting really February, I focused full-time on it and then slowly got a few more devs joining it to make this really go. But yeah, so I think it's quite mature now. We're refining API namings basically and a few things, but the core functionality is there.
We have some experimental branches working on IBC additions, but we're not doing too much there until the Stargate is stable. We have client side and Go bindings for it. So we will have IBC when it's ready, but they have no release candidate and they change the APIs quite often. So tracing master on SDK is pretty much a waste of energy. We did it for a few weeks and we said, okay, we've proven it works. We know the interfaces, we understand what needs to be done. And when the API is stable, we'll have that. So we aim to have that in version 2 of IBC. And right now we're just doing internal refactorings basically to finalize it. Which means I think it's pretty good to build stuff. And so recently I started building contracts, assuming they're not going to have huge breaking changes anymore in our thing. We're coming to a more stable interfaces. And one of my favorite repos now is CosmWasm Plus, which I'm going to send down here. This is a whole series of contracts that try to do things like fungible tokens and non-fungible tokens, inspired by like ERC 777 more, 20 plus 777 plus a bit more. 721, we have some stuff to do proxy contracts, which are interesting. Permissioning choices, working on adding multisigs, and then adding some more stuff like bonding curves, fun stuff in real life. So we're adding a bunch of real world examples there. We have staking derivatives in there as well, atomic swaps, and some usable stuff already, but also building blocks and specs to how to build contracts that fit together well. So I really recommend that as a review. If you want to build your own contracts, look there, see what we did, and then see if you can fit into that. So if you want to build some fungible tokens, look at our CW20 interface and look at CW20 base implementation. You can probably use that a lot. There's a master class on from 2 weeks ago, I think, on building staking derivatives, extending CW20 base to make a staking derivative contract. And that explains that staking derivative contract in detail. So I think that's these are good resources to dig deep if you want to build complex DeFi applications. But for now, I would love to hear what you want to hear. So yeah, the first question: what is more efficient, Cosmos SDK or decentralized application on a virtual machine blockchain? Of course, native code is faster. We are on top of SDK, so we can't be faster than SDK because we don't use it. I think we could actually make CosmWasm as fast as SDK because we do have our own, we have to write our own framework with Rust database storage. There's a much faster storage in SDK uses. There are ways of optimizing various reads they do in SDK, so there's definitely optimizations that could happen there. So we could probably have this WASM code running at similar speed in SDK, but because we have to run on top of the SDK and then add this on top of it and using the same storage, of course it's slower. But that's not really an issue as far as I found. I think we still handle 100 transactions a second easily and scale up with IBC. So the Enigma people who are running encrypted contracts in SGX were clocking 70 transactions a second using CosmWasm technology. So no one's hitting transaction limits yet, and we definitely have room to improve this. But I would say for the big advantage we have here are twofold. If you have an existing blockchain and you want lots of developers on it, so you can throw an application on a blockchain without having to start your own blockchain, right? So you can have one blockchain. If CoralNet is up and anyone can throw the application on it, you don't need validators, you don't need infrastructure. We have a block explorer, we have a wallet, we have a blockchain for you. Just throw your applications on it and you can demo them. That's really fast and easy. And the other is for blockchains themselves. They can develop a lot faster and iterate a lot faster than having to hard fork the code base every time they want to update the code. We have seen how slow the Cosmos Hub updates, maybe 2 times a year. It's fine, right? It doesn't need to change much. But if you want to add features much faster than 4 times a year, the current pattern is probably slower. So, and I actually think it works well with native contracts. So you can build native contracts, and you can build some parts you really want to build native contracts. They need extra special powers, and they want to run super fast or do crypto or whatever else. You build them native contracts. It's great. And CosmWasm can call them. You can add custom bindings for your blockchain to call into your native contracts. So Ethermint, I have nothing to do with. There's 2 questions here. I would like to hear the story behind WebAssembly integration with Cosmos. I like the concept. And the second, how is the functionality of Ethermint different than Ethereum? I don't work in Ethermint.
I think it's was a great idea 3 years ago, and there are alternatives now. So I don't know. I think it's a bit late for Ethermint, honestly. But we took a much more new thing. We looked basically at Polkadot and Near Protocol, which are doing some cool WebAssembly stuff, and a few other blockchains talking about it, and said, well, what can we do on top of, we're actually sitting there in front of the hackathon, and we're making a team. We got like 5 people from 5 different projects together. So let's make a team, let's do something cool. And we talked about cool things like subkeys people wanted, and we talked about various use cases and some DeFi stuff and lots of ideas. This was in Berlin in 2019, June. And it was later and later on Friday night, and someone said, let's build smart contracts, That'd be cool about smart contracts. Hey, let's build WASM. WASM is big now. It seems like it's, mature. Look at, Perry Substrate, look at Ink, look at Near. People are doing stuff. So let's do it. There's a thing called, anyway, there's another Go project. There's Parallel Life, I think, was also doing some stuff with WASM at the time. So we got excited about the idea and said, let's try it. And the later the night went on, the more assured we were that we could, in 2 days, integrate smart contracts in the Cosmos SDK. So then Saturday came in reality, and it was kind of hard. And one library worked, but didn't have integrations for callbacks, and trying to pass buffers of data, not just numbers, was hard. And one thing after another, we ended up on, I think we tried 3 different libraries, ended up in Wasmer. Started getting contracts working. I was writing some pretty ugly Rust that looked a lot like old school C, which I knew, but not Rust. Anyway, and so luckily we had a Rust dev there who just one night while I was, off doing some other Go coding, he just rewrote everything to make beautiful Rust, which is actually our HackAtom contract. If you're looking at CosmWasm repo contract, you see HackAtom is the base of that is what we wrote in the hackathon. It's been refined and updated. We add more features, but the base is there. So yeah, there's so I think that's where we started. We just got inspired and we knocked it out, and we got some simple escrow contracts working in a few days, and we could change them, and we made a new contract in half an hour. A second one, there were some changes to it, and uploaded it again, and saw that on the web. So that was really inspiring for us, and I want to see how much we could do with it, and how easy it could be to write a contract. So that was the way it came from, and I've been basically working on trying to make better UX, dev UX for Cosmos for a long time. So I started with Cosmos 2017, and I left there eventually, and then just built out protobuf backends SDKs, which Stargate is going to finally have in 2018. Myself, another fork, which whatever, and building out JavaScript libraries, which we're building out now. CosmJS is now Cosmos-specific library with full-featured JavaScript library to do everything you need to do. Makes it really, really easy to write web apps on top of Cosmos chains. And now we're at smart contract engine too, because I see the need aspects in the ecosystem. So I'm just working on the tools to make everyone else faster. Blockchain, the Cosmos Hub is a blockchain. I think Terra is a pretty well-known blockchain out of Korea. They have quite a few people using them to send money around. And they have like 4, and they're also integrating CosmWasm in their current testnets. So IrisNet is, Binance is actually building on it. Binance Dex is built on Cosmos SDK. They forked it and made it private, but it's based on Cosmos SDK. IrisNet is also, Kava is a StableNet project, and Secret Network is actually a pretty cool one. They also took CosmWasm, and they actually have gone live with this. They forked our code base, and they're running inside an Intel SGX. So you have secure, they encrypt inputs and outputs, and you have basically secure smart contracts, secret ones, because the data is on the blockchain, and you can interact with it, but no one can read the data. So yeah. Oh, band protocol's running it too. Okay, cool. Definitely. So there's quite a few more moving to it. I think some people, a lot of people took Tendermint and built on Tendermint, and recently a lot more people are jumping on Cosmos SDK plus Tendermint. When IBC is there, it's the holy grail in a way that lots of people build their own blockchains, their own way they want to, their own validator set, their own logic, anything they want basically, and they just connect together. So it's a much, much more open ecosystem than Polkadot. Because Polkadot gives you a lot more, but they have to be loyal. And in this one, everyone has their own token. Every blockchain has their own token, their own validator set, their own economics, their own custom code. And they're all independent, but they connect to IBC, so you can jump any network topology, like the internet.
that should be out, production. They're testing it now, starting to do testnets on it, working with these candidates. But hopefully by late Q4, it should be live. Cosmos Hub is a token called Atom. It's a pretty big one. I think it's on top 20 somewhere, 13 or something now, market cap. And Kava is also on CoinMarketCap. You can find them somewhere, Kava. But I think the other one's much smaller. There are quite a few different tokens out there. All right, thank you very much. Anyone have a great idea you'd like to build for the hackathon? If you want to, I think there's another session around that you might be able to, maybe Hassan can tell you that too. But there should be another session around to talk about ideas. And did you have any questions about the coding of it or anything else and examples you want to see? I can probably point you to code samples or videos or something else. How is Cosmos Network different than Cosmos Hub? Cosmos Network is a concept. It is lots of blockchains connected over IBC, like the internet. And, it's kind of saying, how is AWS different than the internet in a way? I don't know, or web servers. The internet is a concept and it's infrastructure to connect things. Internet is actually a weird word, but yeah, it's kind of like, the connections. And the Cosmos Hub is kind of like AWS or Google is a big central thing lots of people use. And lots of messages are going to go through them. Maybe it's more like a Cisco router, like the gatekeeper, gate routers and stuff like that. But yeah, it's like a major player and a center connecting point for the internet, but allows lots of the knowledge to go on the edges. I recommend really, the pre-built models, I recommend this thing I pointed earlier too. I sent these two links up earlier, I'll send them again. So for resources, please check these docs. We also link the videos on there, all the videos we have, Medium articles, the tutorials in there, it's lots of information. So Arkun has an amazing job organizing that again. I had a pretty chaotic version. It's really clean and easy to read now. If you have questions, please jump our Discord and ask. We support it and we want to make it better. So all of our stuff is there on the docs page for getting up and running. If you don't understand something, make a comment. It explains how to deploy it to blockchain as well and how to query with the JavaScript client. We have nice stuff here. And so from Ophijet, this is some codes there. The CosmWasm Plus is a great stuff that you can actually start building with. Examples is nice stuff too. I wouldn't use the ERC20 there, but there's name service one, escrow one you can use. You can take this option one and turn something into it. But I look at Plus as some nice building blocks, really. We have CW20, I think is a nice building block to build on. And the other video I have referred to, it's linked to from our docs, is how you can extend CW20 to build your own CW20 token. And we should have a CW20 wallet coming out for CoralNet, I don't know, in the next week or so. Pretty soon you should have a wallet. So you can display your CW20 tokens in a UI. We'll have a generic UI, kind of like Ethereum has for ERC20. So if you build on that standard, we can add, on CoralNet, then you have a wallet that you can use already. So please free. Yeah, and so please join our Discord if you have questions. Let's see, and what else? Were there any questions here that was asked for? Yeah, the Discord. Discords are definitely a good thing to join. Please join that. And yeah, any idea, what do you want to build? People want to build. I don't know what the whole focus is. It focused on DeFi or something else? NFTs, voting applications. But yeah, the simplest thing you can do is, take CW20 base and add like a bonding curve to it or something like that, if you want, or figure out how to make a stable coin to fake Oracle. So we have no Oracle right now. So I don't know how to add Oracle to a network. So I'm talking to Band to try to get that in. But yeah, so surprise us. Yeah, so we're definitely working DeFi too. We've built, I think the CW21 is a building block. It's atomic swap and escrow building on it. Uniswap is a desired feature. People could try to hack it out. It's a bit tricky because you cannot use floating point operations. So we don't allow floating point operations because they're non-deterministic by default, and blockchains don't want them.
two different CPU architectures might round off differently. And that's a known thing of floating points. Yeah, Cosmos SDK in general, I think Cosmos.network, docs.cosmos.network should give you, and they have a thing called Starport. So I think that is where it is. And you can look for Starport, which will get you going on your own app. You can start your own SDK app. If you want to write in Go, you can use that. And that's a great place to start. And you can also add CosmWasm and Starport quite easily. Anyway, thank you very much. And if you're working DeFi stuff, you have any questions how to build stuff, come to our chats, talk to us. We'll help you with ideas and maybe help prototype some stuff or review some code if it's, if you have time. But cool, thank you very much for the time.
Thank you, everyone, for joining us today. Hope to see you guys build CosmWasm, like you build your own project using CosmWasm for Cosmos HackAthon India and for Cosmos HackAthon 5. Be awesome. Thank you, everyone.
Thank you.